Hi everyone. Let's get started. We're a bit in a hurry today. So first of all, my name is Kenneth. I am Danish. We used to be the most happy people in the world, but unfortunately the Norwegians are more happy than we are. So too bad. I work for a company called Intel. You might know us from being inside a lot of computers and data centers, but we also work on the web. Actually, I work on Chrome itself, and I work on standards in the W3C. And I'm also a Google developer expert, so I want to thank Google for bringing me here today. So we're here to talk about smart devices. You can all hear me okay? Fine. So the first thing you might wonder about is like, yes, this is the problem of working at a big company. You might wonder like what makes, I'll just put this up, it's not, I think this is better. So, okay. You might wonder what makes a device smart. Like, is it really smart if I want to turn off my light? I need to pick up my phone, unlock it, find that application. Where is it again? Launching it, turn off light. No, that's not really smart when you have like something on the wall, like a wall switch you can just click in less than a second. So when you make smart devices, you need to solve real issues. And you need to be around when you need it. So for instance, if I wanted to turn off my light and my phone wasn't around me, that would be not very useful. And you need to be easy to use and provide what's called low friction. Yeah, and people don't want to download apps. They just want to do stuff at that moment, and they want to do it now. So when you think of a future, people are talking about these futures where everything gets connected to the internet. It might be your heating, it might be your lights, it might be your TV, your radio, everything around you. Well, then apps don't really scale that well. Because you already know Windows, like this is how my Windows desktop looks like. It's like, where is that icon I'm looking for? And it's becoming the exact same on mobile. We have way too many icons. You have a lack of overview, and then you get these annoying updates for apps that you haven't used in a couple of years. Or maybe you never used. You just installed them at some point because you had to. So let's look at some usages. So this is kind of like how I divide groups of these smart devices, Internet of Things. I can group them into 3 different groups. Something that you use every day, like turn on the light, turn off the light. Some you use once in a while, like maybe it's summertime, so you really want your refrigerator to be a bit cooler because you want to have cold beer. Well, then you might use that once in a while. And then you have these apps that you just use like once in your life. Maybe this is like I'm traveling to Barcelona once every 10 years, and I need maybe this special application for paying for, say, a parking ticket. So you can kind of divide these use cases into 3 different groups. So you might wonder, maybe there's a better model. We want the low friction and ease of use. Things should be easy to use without requiring a lot of different steps, like installing things. And everyone gets this on the web. Everyone knows a URL. Just put in a URL, and you get the experience. Don't need to install anything. But people said, like, well, but you know the web, it's too slow. But well, the good thing is that people have really been focusing on making the web faster, especially on mobile. So there's been a lot of focus on this. Some things around like loading modules, what's called HTTP2 push, which is where you can, like, when you get a resource, the server can say, hey, well, if you need like this web component, like Justin was just talking about, maybe you also need this other web component. So let me just send them together. Basically something like Webpack that just happens in the browser. We also have service workers that allow people to make things working offline. Different patterns for how to load these things in a nice way and fast way. And we're getting new APIs for doing more things on the web, like better scrolling implementations. So you can do like parallax effect or whatever you need in your experiences. So first of all, service workers you've probably heard about already. It's kind of like a proxy that sits between your browser, like your phone here, and the internet. So for instance, if you're offline, then instead of going directly to the internet, it can just like go to the service worker, already use everything that's cached and provide that to the user. This doesn't necessarily have to be something that's used when you're offline. It can also be used when you're online to make things faster. Unfortunately, that means that we'll kind of have to say goodbye to the dinosaur and the dinosaur game. But there's a good news here, because Google, they added something called, if you type into Chrome today, about : Dino, you get the Dino game. So it will still stay around. So basically the main takeaway here is that the web is up to task. You can create amazing experiences today that work offline, that are fast and responsive. So let's take an example here. So look at this example. Launches immediately. Very nice experience. That looks exactly like a native app, right? You say, well, that must be a native app. That can't be web, right? I don't see any address bar. It starts super fast, and like there's an icon on the home screen. But this is the experience we call progressive web apps. But this is a lot of new standards around, like adding something called a web app manifest, where you decide like how the application should launch, what its name should be, like a short name, a long name, should it be locked in specific orientation and whatnot. Plus integration with service workers, so it always works offline. There's also good books now. You can buy a good book here by a guy called Tal Ader that allows you to, that explains you exactly how to build these experiences. So the nice thing is that the web is really good for these one-time usages. Like I said, I'm in Barcelona, I need to pay maybe for a parking ticket. It's nice, you just type in the URL. You don't need to install anything. But if you really want to, if it's like your smart light, you want to turn on and off the light every day, well, at that point you can decide, hey, maybe I want to add this app to my home screen, so it's easy and readily available for me. And then when you launch it as a progressive web app, then you don't get like all the URL bars and all of these other things. So no clutter. You get into the really web-like experience. But the main thing about the web is that it's safe. And this is something that we care a lot about when you're working on standards. Because you don't want that when you surf around the web and suddenly it starts connecting to all your home devices and sending all of these information to big companies. That's not what you want. You want the web to be safe. You want people just to be around to explore different URLs without worrying. Which is not the case with like native apps when you install them and they get a lot of access to things on your phone. So you really have to worry, is this really something I want and something I need? But you might say to yourself, well, all these like smart devices that kind of live outside of this sandbox, they're in my home, right? They're not on the web itself. So can I do this with the web? And really you can. But something I want you to keep in mind, this is what I hear a lot from people, especially developers like myself and you. People love technology, but companies and users, they don't really care. They just want things to work. So I'm going to talk about two different technologies today, Bluetooth and USB. So the second icon is the USB logo. And these technologies, it's not like one is better than the other. They work for different use cases, and they complement each other instead. So first of all, let's look at some of these. Let's start by looking at Bluetooth. So Bluetooth has a few advantages. It's widely used, so you see it like everywhere. With the later versions of YouTube since Bluetooth, with Bluetooth since Bluetooth 4, it's called like the Bluetooth Smart or low energy. It doesn't use a lot of power, so it's pretty low energy. It's really nice. You can have like, for small, like a temperature, maybe you can get a battery and have it running for multiple years, even though you interact with it once in a while. So that's pretty nice. It's also wireless, which is like probably the main advantage of Bluetooth. It's also relatively cheap, easy to use, and it comes with some beacon like functionality built in. This is a way for the device to like broadcast itself. So you can maybe have it pop up on your phone and say, hey, I'm around you. Maybe you want to interact with me. Some of the disadvantages like security. Like if you just like send pure text over the wire, like people can like figure out, it's just like radio waves. So people can like actually see what's in the air. It's not really hidden. So make sure that you encrypt your data if it's important. It's also not powered, so your device, smart device, needs to have an external power source like a battery. And of course, there's problem with stability and speed. A lot of different interference. There could be interference in rooms with a lot of concrete. Maybe you're not allowed to use it on a plane or in a hospital, etc. So here's like how it works. So to go to a website, you click on the website. You pair with the device. Here I'm pairing with the one in the middle. It shows a like regular web page. And this is just like the interaction. Changing the color, really frictionless. So Web Bluetooth is a new standard. It's implemented in Chrome. It works pretty well on Mac, on Linux, Chrome OS, and on Android. On Windows, unfortunately, Windows 10 didn't implement all the requirements for Bluetooth Low Energy until what was called like the Creators Update. So Google or the people working on this still haven't gotten around to make it work on Windows yet. But that is work in progress. Also, the good news is that even Microsoft has started working on a polyfill for Windows on Edge. This means that in the future, you might have heard that Microsoft will have progressive web apps in the Windows Store in 10, so in the early next year. All these apps, when they're installed from the Windows Store, they get access to something called Windows Runtime. So existing APIs that are specific to Windows. But they will have a polyfill, like a small JavaScript library you can include, and then you can use the exact same API. It will just work out of the box. So that's pretty good news. As I said before, Web Bluetooth is based on Bluetooth 4. This is what's called low energy, on a protocol, the generic attributes. So it's an easy-to-use API using a modern web API, such as promises and typed arrays. It also means that the old Bluetooth before 4.0, what people don't call low energy or call classic mode, is not supported. Also, you can only, from your phone or your laptop or your computer, you can interact with a peripheral. You cannot turn your phone or your computer into a peripheral itself. So this is only like a client, like a central. So here is like there's a, if you really want to see like how well it's supported, there's a URL where you can go and check the latest status of the spec and implementation. When you're using these very important APIs, I talked about the web needs to be safe. Well, you need to use HTTPS. So this means that it's like an encrypted, secure connection to the server. This is also so you don't get any snooping or anything going on. This is like how it is with every new powerful web API. It also requires you to use a user gesture to interact with the device. You don't want to, like I said before, you don't want to put in the type in the URL and suddenly it just automatically connects to a device around you. So the way it works is like this. If it loads, just a second. Here I'm clicking on the screen and immediately that's a gesture. Then it can show up like a dialog where I can select the device. Here it's showing a heart rate monitor. So this is what I mean by requiring a user gesture. You need to click somewhere for it to show up this dialog. The way it works is that you have this navigator.bluetooth, then have a function called request device. This you can only, if you just called it immediately when you load the page, it will fail. It has to be as a response to a user gesture. Like for instance, on bottom clicked. Then you could call this. Then you can set up some specific filters depending on how your device works. So there are like some standard protocols in GATT, like battery service. Or sometimes with a lot of devices, they use their own like UUIDs. So basically you put in the filter, and then if it succeeds, you get a device back. Sometimes you have devices that support multiple services. So it could be like service A and service B. And you have maybe another device which only supports like service A. So if you want to write a website, that should work always with service A, but use service B when it's available. Then you need to list service B as an optional service. Otherwise, it won't have access to it, even if it's available. So this is just something to keep in mind. Generic attributes profile works this way. You have a profile, and you have services inside with each characteristics. But as I guess most of you know JavaScript, we can think of this in JavaScript terms. So it's basically like a service is something like an object in JavaScript, where the characteristics are like properties. But there is one, so this characteristic could be, for instance, a Boolean or a text string. But what happens in a lot of these protocols, at least with existing devices, is that people try to be efficient. So one characteristic might be like a type array where people pack in different values. So sometimes you get like one characteristic representing multiple things. So let's look at how we do it again. We start by requesting a device. If it fails, you go to the catch here. This is using promises. If it succeeds, you get a device back. Then from a device, you can connect to the GATT protocol. Then when you have the GET protocol, then you can like subscribe to these services, for instance, getting the characteristic like here, the battery level. Then you get a characteristic back, and here a read the value. As this is a binary protocol, you have to use these functions like get unsigned integer 8, etc. This is not like regular JavaScript bools and strings, because that's not how Bluetooth works. Here's another example. You can also write to these, depending on how these devices are configured. So here I'm getting another characteristic called heart rate control point, and I'm writing to it instead. You see write value. Some of these values are very commonly, for instance, if you think about a temperature sensor or the heart rate monitor we just saw before, they continuously give you new values. So instead of just having a read and write, we also have a notify. So it means that instead of that, just when you have one of these values, characteristics, you can attach an event listener called characteristic value changed. And then every time the value changes, you can do something with it. So that's like really simple how Web Bluetooth works. So let's look at bootstrapping. So I was talking about like Web Bluetooth having, or Bluetooth having some kind of beacon functionality built in. So Google built something around this called Eddystone. This allows these devices to advertise themselves using URL. So basically say, hey, I'm a heart rate monitor. This is my web app, or this is my website where you can interact with me. It could also just be something else where you don't actually want to interact with it. You just want to like promote a web page, like a movie poster saying, hey, this is go to starwars.com for the new movie. So it will work. It shows up. This is how it used to look. It's slightly different today. On Android, you need to enable it yourself. So you need to go into Android Nearby and turn it on. So that's in settings. When that's turned on and you get in the proximity of one of these devices, they will show up as these physical web links nearby. So there's an example from a company in London where they use these at the bus stops. So you could basically, when you go to the bus stop, you can pull up your phone and it'll say, hi, I'm the bus stop app. Click here for like when's the next bus arriving. And you get this nice progressive web app experience where you can see when the buses are arriving. So you can imagine this could be used for a lot of things, like for instance, payment, like for parking, etc. So that's basically Web Bluetooth. And here's one URL where people can learn more. And I'll share these slides later online. So let's have a look at Web USB as well. So Web USB is also widely in use. You probably all use USB for charging your phones. It's really cheap. It's cabled. So that's the big difference between Bluetooth and USB. This also makes it more secure. There's nothing in the air that you can easily snoop. You have to have like a physical connection. It's fast and it's really stable. And furthermore, you can even use it to power the devices. They don't need to have a battery. Sometimes they only turn on when you actually plug something in. And I think I actually might have an example. I haven't even tested this, so let's see. I got this very nice example here. It's a very USB device, and let's just see if it actually works. So I'm supposed to plug this in. And then I should go, this on Windows it doesn't show up a dialog, but let me just search for this. It's Web Lite. Web USB. If I could be so lucky to actually find this. There it is. So I have to grant it access. It should have already. Yes, reload. There you see, so Web Lite. If you don't see it, I have to press plus. It will find my device here, Web Lite. And let me see if I can show it to you. You see it's blinking green. And now I should be able to change the colors. So now it's blue, now it's white. And let's just choose some random color, maybe red. And then it changes. So this is just showing like how easy you can do something without having to install any software at all. Just accessing a website and a USB device. So let's just turn it off so I don't get blinded here. So that device was also, of course, powered by my laptop. So you can say one of the disadvantages with USB, depending on your use case, is that it is cabled. but it has no like radio interference. And the good thing, for instance, imagine that you have maybe a big machine in a company that you want to have like configuration app for that. But if it's USB powered, maybe you can have like a latch in the wall. You actually have the physical key to open it up to actually have that connector. So in that way, it can also be really secure. Instead of having people walk into your factory with a phone and finding the Bluetooth connection and trying to hack it. But keep in mind that these two technologies both have their advantages and disadvantages and work very well together. So here's one example of something I did. So you see one device here. You see it's an IoT device. It's powered by USB. So I'm plugging in USB. Now it will take like 3 seconds to load because it can be flashed in 3 seconds. So you see when the light turns on, it's loaded. It shows up as dialog because they added some special headers for that. If you click on that, it will actually load a web page. So this device actually runs JavaScript. So the cool thing is I made this little web app. It has the web USB permission, as you see, and I have some JavaScript. Now I can press run, and it will actually put this code on the device and run it. So it has like a small temperature sensor. That's the black thing there, and it has like an LCD. So if I press run, you should start seeing the temperature. And now just to show that it's live, I actually have different examples. So I have one for an RGB LED. So if I press run, it should stop showing the temperature and change the colors of the LED instead. So it's just like showing like the power of these new web technologies, what you can actually accomplish. And like here, there's like no friction. I didn't have to install any software at all. I could just like plug things in and get started. So this was what the exam was showing, like a device running JavaScript, that it had this dialog where you could find the web page, and it was powered over USB. So USB is a bit different than Bluetooth. It has 3 different modes. One called bulk, it's probably the most common one called interrupt, and one called isochronous. It's a very complicated word. So let's explain these. So bulk transfers are the fastest. It means that you bulk things together, and then you push it to the device. So this is what like printers and serial devices normally use. But this wouldn't be really nice, for instance, for a mouse or a keyboard, because like when you type on a keyboard, you actually want to see the letters as you type, and not like when, oh, now you have 5 letters, now we show them, and now we get the next 5. So for this, you have something called interrupt. So instead of being the fastest, they like guarantee a maximum latency. So for mouse or keyboard input devices, this is the thing you should use. And then of course you all have like your web cameras and audio where you just want to get as much online as possible, like a live streaming, just put it on there. If you're missing a frame or two, I don't care. It needs to be live. We don't want any delay. So this is what isochronous transfers is for. Web USB, USB itself, on the devices, you add a few headers. So it has a few extra headers for web USB. They're optional, but they can add like extra security and restrictions. You can also use this for adding like the URL thing that I was just showing in the video. I can also do things like saying this device can only work with this one website. So there are a few extra things for restricting things. So this was the dialogue, just like another way of showing like how it could look. You can put like a website in there. There are a few, I'm just listing this in the slides for people to look at later. There are a few issues on some platforms, especially with USB, because the host, your OS, likes, for instance, to take over like a keyboard and a mouse. So if you just like write a new keyboard device and want to use that on the web, well, probably Windows or Linux will say, hey, that's a keyboard, it's mine. So they'll claim the devices. So sometimes, even though, for instance, with serial devices, you can do the exact same protocol, but you should just like call it something else, so that the host OS wasn't like trying to claim and steal your devices, because that does happen. So the API is very, very similar to what you saw with Web Bluetooth. Here I'm using promises, but on the web we're today having something called async await, so this can look much nicer. It's much easier to understand. So you get a device, request device, so filter like the other one. There's a few differences because of how like USB works. So you need to open a device, then you have to select the configuration, claim an interface, and then you have like this control transfer, and then you can transfer things in and out. So it's kind of like a master-host, master-slave thing. But actually, when you get over like how USB works, it's actually really, really easy to work with. This works today in Chrome on Linux, Mac and Windows. And I've heard that Microsoft might also provide a polyfill for Windows in the near future. So really cool. And as before, here's another URL that can get you started with this new technology. Wow, I guess that was a lot about hardware devices. So I'm sorry, but we have a bit more. Because many companies, they actually like to track stuff. So this is like a common case, like maybe you're a grocery store, you have products coming in and out. So you want to read things and track things, or you want to get like information for things about things around you. So maybe like these beacons, like I was talking about, like Bluetooth, that just like advertising the URL, maybe that's the best solution for your use case. Maybe sometimes just NFC tag, where you actually need a physical connection to the tag itself. Or sometimes you just want like QR codes because they're very cheap. You can just print them and scan them. So actually, it's behind the flag in Chrome. We're getting a lot of new cool APIs. So this is a new API actually called the Shape Detection API. It's called Shape Detection because it's not limited to barcodes and QR codes, but it also works on things like finding faces in pictures or video streams or eyes or noses and whatnot there will be in the future. But here's one of the cases, one of the APIs that comes with it is a barcode detector. So you can actually take a picture or take a live stream and actually from the web detect these. And then you get a number out and you can deal with it the way you want. For NFC, this is another API I've been working on myself. So this is kind of the same. It allows you to have these NFC tags. So NFC tags, well, with NFC, there are peer devices, or they're active powered devices and passively powered devices. Most people care about the passive powered devices. These are something like tags. So when they don't have any power inside them, but have a circuitry. So if I take one of these and put my phone next to it, my phone would actually make like a magnetic field that will power up that device. And in that moment, it can exchange info. Like you can read what's on it and you can write to it, if it's not made like write only. So we will have a new web API where you can actually write to these devices as well. So here's one example. I made like see, here I'm writing things using the push message, and here I'm watching for touches with a watch function. So if it's empty, I push some data to it. So we made really nice integration with JSON. So I'm just giving some JSON here with first name, my name. Next time I tap it, when it's not empty any longer, I call this processed function. And you see if I find JSON, I'll actually go and write out like hello. It will say hello, Kenneth. So really easy to use API. And I thought it was pretty cool because I was showing this to the inventor of the internet, Sir Tim Berners-Lee, and he was also really excited. So let me show you how this works. This is one of the examples I made. This should be a video, yeah. So you have like, I made this small application. It's actually a Polymer application, so it's also with web components. So I can write a name, what I want to configure a tag. So imagine I place these around my home, next to my washing machine. Maybe I can, and now I wrote something to it. I think I wrote milk. So if you tap it again, it will add milk to my shopping list. And just to show it's live, I'm writing cocoa, like chocolate milk, to it. And yeah, you need to press it the right place on my phone. I don't know where the NFC thing is. And then it failed. So we just try again, and there it go. So now you can see like like that. You get like different things. I already configured these, and then at the end you should also get cocoa. Yeah, I got cocoa there. So beer, banana, pear, cheese, milk. So this like shows like how you can use these new APIs. But I always get this, like people say, but sometimes you have these devices around you, especially you want to like control and receive data, like a temperature and whatnot, like sensorial input, like sensors. And my phone, it already comes with a lot of different sensors. Like, I don't know, there's a gyroscope, there's a barometer, maybe there's a barometer in there. So wouldn't it be cool if we can just access these from our web apps and do like all these cool experiences? So we thought, yeah, that's a really cool idea. But we want it not just for the web, we want it in a way that we can do these things on IoT devices as well, using the exact same API. And maybe work with Node.js and things like that. So we came up with this new standard called Generic Sense API. It was also created because the existing device APIs, like device motion orientation, had a lot of issues. So we had like all these new APIs, like gyroscope, magnetometer, accelerometer, ambient light sensor, and whatnot. But one thing I figured out when I started working with sensors is that you cannot buy any book that tells you how to work with these sensors. What is a gyroscope? What's an accelerometer? How do I use them together? How do I merge input? So I ended up writing this motion explainer myself, which you can check out. It gives like at least my best understanding of these sensors. So very easy to use API. Should be really easy. Just create the object like an accelerometer. You can put in some options like frequency. And then like, even if it exists or not, it will create. So no, you cannot fingerprint anything here. First, when you actually like call start, it will either fail or not. But it might fail because you're putting like a too high a frequency and whatnot. So here's like one example where I'm showing that you can merge like two different, I'm using like an accelerometer, like a gyroscope, an accelerometer to create like an orientation sensor using an algorithm called a complementary filter. I'm just showing you like in a few lines of code you can really accomplish these things. So I'm just having some cool, we don't have so much time, so I'm just showing you a cool video. Because I had this sensor at home, this Daydream controller. So I thought, hey, couldn't I use this to expose it over Bluetooth, web Bluetooth, with the exact same API, and then actually control my app? So this is exactly what I did. And it took me like half an hour with the exact same API. And I thought, well, I also have like this device at home. And I just like showed you it runs JavaScript, so and have that one. So let's try with that one as well. Another half an hour later, that also worked. And here is actually pretty cool because let me just like show you how much code it took. So this is the code on the device itself. I think it's 68 lines of code. There, 68 lines of code. I'm getting the data and I'm packaging using like unsigned integers. And this is I created like this fake sensor called Zephyr controller that exposes it as these generic sensors. So there's like 71 lines of code on the other side. Like almost nothing. I think this really shows how powerful these things are. So I think like we can say the web is really ready for creating like nice app-like experiences today. And you can effortlessly connect to all these kind of new devices over even Bluetooth and USB. Currently in Chrome, soon maybe on Windows, and hopefully on other browsers in the near future. New APIs such as NFC readers and barcode readers is coming as well, and is currently behind the flag in Chrome. So you can also start playing around with this early and give feedback. Generic sensors is also in Chrome today. It's behind an origin trial, and it will be shipping very soon. I'm currently myself working on making some polyfills, so you can also use this polyfill on iOS. So it's not like you just code for Chrome. So you can actually start to use this in real application very soon. So with that, I would like to say thank you for listening. And if you have any question, come find me later.
Thank you, Kenneth.